Again, we're going to look at independent events for this. So, here we go. When the occurrence of one effect has no effect of the other event, meaning they're independent from each other. They're not going to affect the probabilities at all. Flipping a coin and getting a heads or tails in one event will not affect me rolling the dice on the second event. Does that make sense? Flipping a coin on one event, heads or tails, flipping it again will not affect the outcome again. Does that make sense? They're independent from each other. To say they are not independent, okay, here's your example. To say that something is not independent would be the following. Let's say I have a bag of candy, and there's 3 pieces. It's chocolate, it's sour gummy worms, and it's Skittles. My first event is that I pull one of the candies out. Happens to be Skittle. Will that affect my second event if I decide to get another piece of candy? Yes, it will. The first time we have 3 of them, we have a total number of 3 events. We have a number of 3 elements. The fact that I take one now, we now have 2 elements. It will change up the probability. That would make it non-independent or non-independent. Does that make sense? So one will affect the other, and that's how we want to answer this. And today, we're only looking at independent events. And we're going to see whether events are independent depending on what we're going to show. Our example here, you flip a coin and you roll a cube, even at the same time. Flipping a coin is a half of 1 1/2, right? It's either heads, tails. Rolling a dice and getting a 3 is either a 1 out of 6 chance. These are independent events because one will not affect the other. They're independent from each other. Yeah, we're good? You don't need to copy this. I just want to talk about the one before, yes. This one you don't. Let's just talk about whether they're independent or not independent. You flip a coin and then roll a fair 6-sided dice. The coin lands heads up and the dice shows a 1. Independent, yes or no? Yes. Flipping a coin and rolling a dice won't affect each other. They're not going to affect the outcome of whatever one you get. Independent. 2, a bag contains red marbles and 4 blue. You randomly pick up a marble, so we randomly pick one up, and we pick up the second marble, we put it back in, or we don't put it back in, we pick another one up without returning it to the bag. Are those independent or dependent events? Or they're dependent. Because the fact that we pull one marble out affects all the other marbles in there. Because now we have one less, there's a more chance of getting the other. Or there's one chance of getting less than the other. Because we're not replacing it. If we were to change it, we pick up one yellow marble and we mark it down yellow, and we put it back in, and we pull another one out and it's red. Are those independent events? Because we replaced it. It's not affecting the outcome. Right? We're having the same probability. Next one. A box of chocolate contains 5 milk chocolates, 5 dark chocolates, 5 white chocolates. You randomly select and eat 3 chocolates. So in the box, we just choose 3 of them. We grab 3 of them. The first piece is milk chocolate, the second is dark, the third is white. How many people say it's independent? Why do you say it's independent?
Because you chose one from each kind of chocolate. And you have the same amount.
Does it tell you how many dark chocolates? What if I had 20 dark chocolates, 1 white, 1 milk, and you happen to just choose those 3? You have an even chance? Did the event occur all at once? Or did you eat one, then took it out? And then did we eat another one and then took it out? Or then, do you see the difference of how I'm asking this? So are they independent or dependent events? How was the question asked? Did he pull out one at each and ate it and then went back in the box? Or did he grab all three at the same time? Does it say all each? He says, you randomly select three. He grabs three. So what would it be? Independent. It's an independent event. I picked three. I put my hand in the box. I pull out three candies. I ate three of them.
You're just saying off the part where it's like one white chocolate, one dark, and
He's just telling you what he ate. He ate one of each. He happened to pick one of each. Independent events. The question can be switched. Has the same kind of setup. You randomly select one chocolate at a time. The first time he picks up a milk chocolate. The second time he picks up a dark chocolate. The third time he picks up a white chocolate. That would make them dependent. Because every single time he goes into the box, he's now changing up the probability. It's one less than the previous one he had. But if he got three all in one go, it doesn't change anything up. Cooler contains 10 bottles of sports drinks, 4 lemon flavored, 3 orange, 3 fruit. 3 times he randomly grabs a bottle, returns to the bottle, and mixes up the cooler. The first time he gets is a lemon drink, second and third times he picks up a fruit punch. Independent or dependent events? Dependent. He drinks a sports drink. He goes back, he puts his hand in the box, he jumbles it around and picks up another one. The fact that he pulled one of them out and drank it and threw it away changes up all the probability. How many times he returned to the cooler, right?
He returned the bottle.
So yeah, you're right. Independent because he returned it. It's independent events. Exactly. I read it wrong. Is that making more sense? I just wanted you to see the idea behind independent dependent events. Here we go. If it's asking us for independent events, we can actually determine whether events are independent of each other. The way that we're going to do this is the intersection. The event A and event B are intersecting each other, being that probability A times probability B are the same. Would these be independent events? Whether you're having a good day would be event A, event B would be that you're wearing jeans. Independent. One does not affect the other.
What if you're not happy about the jeans?
Generally, they don't. Let's just say generally. To make them dependent events, we can say, let's look at a dependent event. Trying to think of a good one. A dependent event would be something like this. You wearing a shirt and going to school. Would that be a good one? Be dependent if you go to school.
And you can't go to school.
Then you can't go to school. Can't go to school. So you're assuming that you have to wear something, right? You wearing a shirt is dependent on you coming to school, right? Well, how about wearing pajamas? Right? If you're going to be wearing pajamas, would it be dependent on you coming to school? Yeah, you can wear pajamas, but mostly likely not. Okay. You have. I've seen you before. No? Okay. So that's our setup for this. That's going to be what we're going to look at a lot. And we're going to still look at two-way tables, but we're also going to calculate whether these are independent or dependent events. So here we go. Copy down the chart. Just want you to copy down the chart. Are these independent events? We're going to determine that. Does taking vitamin and eating regular Are they independent? Meaning, do you have to take vitamins to be? Taking vitamins depend on you exercising? We'll see. We can actually determine these two events if we take them. And we're going to look at that. And the way that we're going to calculate that, we're going to look at whether these two are equal. Our equation, the intersection of taking vitamins and exercising, is equal to the probability of the vitamins and exercising. If those two are equal, then yeah, they're independent events. But if they're not equal, they are not independent events. Meaning they are dependent. Meaning one relies on the other. Meaning if you probably take vitamins, you're probably working out. Possibly. You eating dinner is probably because you're hungry. Whether you're eating dinner or not is probably whether you're hungry or not.
I mean, what
We're depressed. What if we're depressed?
That's how stressed mom forced me to eat something very
How about this? The likelihood of it happening. Right? We talk about probability. It's the likelihood of it happening. The technicalities. Kill me here.
We're preaching a lot of crowd here.
I know.
That instant for everything.
How you do.
What?
So
What?
let's look at this. Taking vitamins and exercising. We're looking, and this is messing up again. Come on. Taking vitamins is going to be looking at category. We're also going to look at exercising regularly. Probability of taking vitamins and exercising would be what probability? $48 of what? Of how many people both exercise and take vitamins?
120.
Of 120. Is that equal to the probability of taking vitamins versus those that exercise? What's the probability of those that exercise?
76. Wait.
48.
Yeah.
Sorry, vitamins. We'll do vitamins first. Taking vitamins would be 48 of the what?
60.
48 of the 60 take vitamins. We're going to multiply that by the ones that exercise. How many exercise?
48
Over 76. Are these two equal? Let's check. If we reduce these down, 48 over 120 is going to be 0.4. 48 times 48. Divide that by 60 times 76. Are these equal?
No.
So are they independent? No. So what does that tell us about this information? It's dependent on each other. You taking vitamins, probably you're working out. It can be a multiple reasons. You're doing it for health reasons, just to be healthier. You're taking vitamin supplements so that you can get stronger. I don't count vitamins as steroids, but yeah, you're taking some kind of medication. We'll consider vitamins medication. Okay, so yeah, they're dependent on each other. Those that usually take it will be dependent on that value. Here we go. Let's look at another one. Here we go. Copied on the chart. This is asking people that know how to ride a bike and know how to swim. Does any of your parents don't know how to swim? My mom doesn't know how to swim.
My dad doesn't know.
Doesn't know how to swim. Yeah. We have a pool. I've had a pool my whole life. My mom doesn't know how to swim. Questions? Yeah. Yeah. Since you were 2, it's pretty impressive. Yeah, and drown.
My mom doesn't know how to ride a bike.
Ride a bike? I have a good friend that doesn't know how to ride a bike. Yeah, she doesn't know how to ride a bike. That's funny. It's kind of like, you're like, just get on, just ride it. I guess it's not that simple. How about this? How many people know how to roller skate? How about this? How many people know how to skateboard?
My skating is trash.
How many people know how to snowboard?
Snowboarding is not fun.
Snowboarding is so much fun. So much fun. So much fun. So much fun. Huh? That's fun. How many people know how about this? This is a little bit more selective. How many people know how to wakeboard? Wakeboard. Wakeboard. When you get towed, it looks like a snowboard in the water. You're towed in the water? Those are fun. That's fun. Oh yeah, you can eat it hard. You can eat it hard. That's like skiing on the water. You can ski in the water. Wakeboarding is way harder. Way harder. Really hard. Super fun though. We used to wakeboard a lot. Yeah. My mom and dad have a boat. We usually go on a boat. Yeah. I don't know how to pull my whole life. Yeah. She needs a floaty all the time. She needs a floaty. My mom will jump. My mom, whenever she gets into the lake or whenever we go on the lake, she wears like a life vest. She's afraid of drowning. You got to. Oh, they're from, yeah, rented. Don't buy it. Let's check to see if these are independent events. What is the probability of being able to bike and swim? 30 of the 60 know how to bike and swim. So half of them. Is this equal to the probability of knowing how to bike? What's the probability of knowing how to bike? 30 of the 45. You guys are getting this right on. What's the probability of 30 over? It's not. You don't know that. You don't know that. If you were to reduce this down and we would actually multiply these out, 30 over 60 is 1/2. And we're going to get 1/2.
What?
30 times 30. Let me just do this. I'll just do it. 30 over 60. 900 over 1800. Multiplying. We're multiplying. This is going to give us 1/2 is equal to 1/2. Are these two equal? Yes, so are they independent? So it doesn't matter whether you know how to ride a bike to know how to swim? No.
Yeah.
That's still kind of fun.
It happens. Okay, here we go. Okay. Copy this one down. Copy this one down. This is the only part we're going to write. Then we're done. But this is not bad today, right? This is not bad today? Not bad, right? Huh? Oh, no. All my friends try to get me into skateboarding. I never got into skateboarding. That's too big. Oh, are you talking about Heelys or Achilles? No, we want to be able to set these up, and these might seem a little bit more complicated, but we're going to be fun. Okay. with this, we're going to look at several key things. It's given us a probability that we want to be able to find. It says, find the probability. We're going to say, R is choosing a red marble. How many red marbles do I have in my set?
15.
How many yellow?
17.
This is choosing a yellow. How many do I have in my sample?
32.
Now, this is what we should be able to just get from the information, right? This is going from the beginning couple weeks or the beginning couple days of this material down. Now it's asking us to. It says find the probability that the first marble you draw is red. After putting it back, the second marble you draw is yellow. So this is looking for the probability of red and yellow using replacement, meaning they are independent variables. We know this to be the probability of getting red times the probability of getting yellow. We can't look up how they overlap, but we can find the probability of each of them. Can you tell me the probability of my red? So 15 of the 32 is going to be red. We're going to multiply that by our yellow. So we're going to look at 17 of our 32. It was either that or making it super light and then you can't see it. It's mustardy. Or gold. I would go with gold. I like gold better than mustard. I just don't like mustard, so. It's disgusting. I hate ketchup.
Yeah.
I like chili. Chili on my hot dogs. Okay, there's a 24% chance. Now, this is what I'm looking for. Your answer is just going to be the fraction. I'm okay with that. I'm just telling you the percentage of it. There's a 24% chance of first getting a red, then putting it back, and then drawing a yellow. Fourth of a chance, not bad. That's it. Is that easy or hard? Do you want me to do a little bit of homework problems with you guys?
Yes.
Put all of them for you guys? I didn't give you guys the answer to yesterday's, right? Here's the answer to yesterday's. Check out your answers. I believe I have a small error. Yeah, I can see it. There's an error in one of them. This will be 28.
What about 12 over 1?
Did they make a movie as well?
Yeah, 9 density, 9 over 85.
Which one?
The one on top.
Yeah, 12 over 102.
Yeah. Okay. So check those for you guys real quick. Yeah, so small. Can you see me? Stop hurting, guys. We're gonna do that once again. Okay, here we go. Starting these out with you, I'm just gonna do a couple of these, probably 1, 4, and 5. We want to be able to first determine whether these are independent or dependent events. Looking at these, I'm gonna reset this. Looking at our first one, it says the following. Draw a king from the deck, keep the card, and pick another from the deck. Dependent or not independent. So it's going to be not independent or dependent if you want to put that. Spin a spinner and it lands on 2. Then you spin the spinner again and it lands on 5. Independent. You can do the other 2. The next one, it says calculate the probability, and we're assuming that these are independent events. Okay? A jar contains 20 red, 18 yellow, 12 green. 12 or 10 gray. What's the probability that you draw first, or you draw a gray marble and a red marble on the second? So we're going to look at the probability of doing gray. Let me do it in a different color. Probability of gray times the probability of red. Probability of gray is going to be what? Of the 60 times probability of the red. You guys probably have a lot more room, so I'm just going to let you guys do that. 10 times 20. 1/18th chance of that happening. Not horrible odds, but not the best odds. What's the probability that you draw the first one being yellow, then the next one being green? We're going to do yellow and green. So probability of yellow. So we're going to look at yellow. Yes, you're right. Yellow times green. So my yellow probability would be what? 18 over 60. Good. And our green probability? Over 60. Three-fiftieths. Even worse odds than that. What do we do for the last one? It says probability that you draw green both times. So we're going to do probability of green and green. P of G times P of G. 12 over 60 times 12 over 60. 144 over 3,600. Not 25, 1 over 25. If it was 25% chance, we'd say 1/4. And there you go. That's how you want to be able to set up a lot of them. Try to work your way through them.